On this problem, you're asked to evaluate an expression, a minus 5b. That's an expression because it's a quantity, it's a number. It's not an equation, it doesn't have an equal sign. So there's not anything we can do to solve that expression. We can't figure out what a and b are just from what's written in that red box. We have to be told what a and b are, and then evaluate the expression, find its value based on those values of a and b. So what did you do to get that process started? Let's say Nifendi, yeah.
Replace the number given the numbers and replace them.
Exactly. Our first job in evaluating an expression is to take the values that we want our variables to have and replace, in the expression, the variables with their values. So that's when I said that this looks like an algebra problem, but it very quickly turns into an arithmetic problem. That's exactly what that step does for us. Right? It turns it into just arithmetic. So how I like to do this, and this I think really helps to thwart some sign errors. How I like to do this is by replacing each of the variables first, before we start throwing the fractions in there. Replace them with empty sets of parentheses. So I'm going to have this green set of parentheses represent what used to be my a, and I'll put in a blue set of parentheses over here that's going to stand in for my b. And the reason that that matters, I'm going to put the rest in here, minus 5. The reason that that matters is that now, for example, when I go to substitute negative 5/6 for a, so now I'm going to put in the negative 5/6, and I substitute 7/12 for b, there's a couple things that happen. First of all, whatever negative sign might have existed on one of my quantities that I'm substituting, that negative sign stays with the quantity as we substitute. Sometimes one of the easiest places to get screwed up with negative signs is you put a negative next to something else, like a subtraction sign, and then you don't see it anymore when you move forward. So starting every substitution by putting some empty parentheses where the variables were, great tip. I picked that up from an algebra textbook a few years ago, and I've been recommending it ever since because I think it really helps to organize your thoughts. The other thing, and there were a couple of you that made this error on the module quiz on Monday. Another thing is that placing a 7/12 right next to the number 5 has the danger of looking like this. And if it looks like that, how do you read it? 5 and 7/12. What's the difference between 5 and 7/12 and 5 times 7/12? Well, yeah, there's a big difference. Because in a mixed number, and I don't use mixed numbers as a practice. I know some of you did on the module quiz, and I let it slide, but I don't like mixed numbers for a lot of reasons, one of which is that they have hidden arithmetic. When you say 5 and 7/12, what you really mean is 5 plus 7/12. Right? And that's not what we have in this expression. And in our expression, we have 5 times 7/12. So I don't like mixed numbers for a lot of reasons. If you want to change your final answer ever into a mixed number, you can do it if you want to. I won't require you to. It does help to give some general overall sense of the magnitude of an improper fraction. But for most other purposes, and especially for the purposes of calculating, mixed numbers are bad news. Stay away from them. And using the parentheses here reinforces that that's not what we have. What we have is 5 times 7/12. So that I just made a lot out of this one step that probably in your own work was a very quick step. Right? Just put the numbers where the variables were. I guess that's what I do. I think that there's a lot to be gained from really overthinking these processes a little bit to pinpoint the places where people make very common errors. So now that the variables are in their places, what did you do next? Yeah.
Multiply 5 times 7/12.
All right. And why did you multiply first?
Order of operations.
Order of operations, exactly. So another place where people often go awry is if you read this expression from left to right, if you just verbalize what you see here in this expression, you'll say something like negative 5/6 minus 5 times 7/12. And if your brain reads it from left to right, the first thing it sees is that subtraction sign. Right? Negative 5/6 minus 5. And so sometimes people from there will say, oh, negative 5/6 minus 5. I got to do that first. When in fact, the order of operations guarantees that before we do any subtracting, we have to finish all of our multiplying. Before we do any s, we have to finish all of our m. So, I agree. First thing we want to do is multiply 5 times 7/12, this product right here. So how do you multiply 5 times 7/12?
Take it as 5/1.
Yeah.
Just multiply across.
Yep, this is a place that that I feel like I see people stumbling a little bit sometimes, or at least having to remind themselves about how it works. We don't really know how to multiply a whole number by a fraction, but we do know how to multiply a fraction by a fraction. We talked about this on Monday. How do you multiply a fraction by a fraction? Straight across, exactly. So if we can turn that whole number into a fraction, then we know what to do. Now we're most of the way home. And how do you turn any whole number into a fraction? Just give it a 1 as a denominator. So throw a 1 underneath the whole number, and then it turns it into a fraction. And from there, we know what to do.
I have a question, sir.
Yeah.
Why can't we,
It's a common error when multiplying a whole number by a fraction to either accidentally or intentionally try to multiply both the numerator and the denominator by that whole number. But as we talked about on Monday, when you multiply a fraction by the same thing in the numerator and the denominator, how does that fraction change? Doesn't. Multiplying by the same number in the numerator and the denominator does not change, it doesn't accomplish anything at all. It leaves the fraction's value exactly the same. But here we're trying to multiply this fraction by 5, which is a change. So we do need a different fraction coming out the other end of this process. Anytime you multiply a whole number by a fraction, don't do anything. Stop yourself before you even go forward and turn that whole number into a fraction first. So that now you have the mental cue, oh, I'm multiplying 2 fractions. And I know what to do, because when you multiply fractions, they multiply across. There's a lot to remember, seemingly, in algebra. But the hardest part about remembering it is having the cues. The little hints and tips that tip you off to what to do next. It's not like people don't know how to do this stuff. It's that you don't remember to do what's necessary at a given time, right? And so for me, anytime I see a whole number in front of a fraction, that's my cue to say, don't do anything, turn it into a fraction first, and then worry about what happens next. So when you multiply these 2 fractions, you end up with 35 on top and 12 on bottom. And we still have a subtraction sign in front of that. And just so that it doesn't get lost, we also have that negative 5/6 that we started with, that we haven't done anything with yet, but we're going to have to real soon. So I have negative 5/6 minus 35 over 12. So now that all of our multiplication is done, now we can add and subtract if we need to. Order of operations, we're all the way to the end of it. So we have to carry out the subtraction. And this is where we were saying we've got a lot of minuses going on in here. Let's make sure that we don't commit another sign error along the way. So here's my recommendation on handling negativity in a fraction. Say I have let's just pick a simple fraction, 1/2. If I put a negative sign down in the denominator, let's say, 1 divided by negative 2. If I were to ask a calculator what that number is, what do you think it would say? As a decimal, 1 divided by negative 2. What if I flip it upside down for a second? Negative 2 divided by 1. That's just what happens when you divide a number by 1. Yeah, it's negative 2. So if I divide a negative by a positive, what kind of number do I get? Negative. But what if I divide a negative by a negative? Positive. So both multiplying and dividing have that same property, where if I multiply 2 negatives, I get a positive. If I multiply 2 positives, I get a positive. So a quick way to say that is if I multiply two numbers with the same sign as one another, I get a positive answer. When do I get a negative answer? When my numbers have opposite signs. If I multiply two numbers that have opposite signs, the result is negative. So the same thing also holds true for fractions. If I divide two numbers with opposite signs, the result will be negative, always. But the good news about that is that it doesn't matter which of those two numbers I'm dividing has the negative sign and which one has the positive. It only matters that they're the opposite to one another. So what that means is that if I have a negative sign in a fraction, it doesn't matter whether it's upstairs or downstairs. So I can move it if I want to. And that's going to be my recommendation for handling negativeness in a fraction, is keep negative signs upstairs. Keep the minus upstairs in a fraction. So where a fraction represents a negative rational number, try to keep it so that the numerator is carrying that negative rather than the denominator. So for example, negative 5/6 in this. It's written as a negative number because the negative sign is out in the front. But if I want to understand it better, if I want to make it a single fraction, I'll put that negative sign on the numerator. So negative 5 on top divided by 6 on the bottom. And then the same is true for the 35 over 12. We're subtracting. But subtraction gets us in trouble, especially if we have other negative signs around. So I like to change subtraction wherever possible into addition instead. How do you change subtraction into addition? Like if I wanted to do 7 minus negative 10 or something, how could I change that subtraction problem into an addition problem?
Turn the signs into positive.
Turn.
Taking away negative.
That's right. Subtraction, by definition, is nothing more than addition of the opposite. Right? So to subtract negative 10 is the same thing as to add the opposite of negative 10, namely positive 10. So you can always turn, and probably should always turn subtraction into addition, because missing that step gives you more potential for sign error. So subtracting 35 over 12 is the same as adding how much? Subtracting is the same as adding the opposite. So to subtract 35 over 12 is the same as to add negative 35 over 12. And to add negative 35 over 12, I'm going to put that negative sign, again, upstairs in the fraction, so that all my negatives are dwelling in the numerators, and my denominators are positive, which is nice, because the denominators are the next thing we have to worry about. So now that we're ready for the addition step, what's our first play in order to add these two fractions? We need a common denominator. Anytime we're adding or subtracting fractions, their denominators need to be common before we can do anything with them. So we need a denominator which is common to both 6 and 12, a common multiple of 6 and 12. What works? 12 happens to work, yeah. That's the smallest number that we can make a common multiple of both 6 and 12. The virtue of using 12 also is it means we don't have to change the fraction on the right. It already has a denominator of 12, numerator of negative 35, right? But the fraction on the left doesn't. So how do I have to change negative 5/6 in order to get it to be a denominator of 12? Multiply. By how much? 2? Yeah. Right. And how'd you know it was 2? Yeah, exactly. To turn 6 into 12, multiplying by 2 is exactly what we would have to do. But if I multiply the denominator by 2, I also need to multiply the numerator by 2. Whatever you multiply one part of a fraction by, the other part of the fraction also has to be multiplied by. So what's my new numerator? Negative 10. Negative 5 times 2. So now our denominators are common. Negative 10 twelfths plus negative 35 twelfths. Once the denominators are common, how do you add a pair of fractions? Add them which? What are the thems that we're adding? Upstairs. The numerators. Negative 10 plus negative 35. Okay. I'm going to actually slow that step down for a second because this is another place where it's very easy to go awry. What is negative 10 plus negative 35? Negative 45. I agree. So that's the right answer. What are some of the wrong answers that you could imagine coming up with for that? 45, that's one. Why might you come up with positive 45? What might be going through your mind there? Two negatives is a positive, exactly. So if you're thinking negative and negative get together and make a positive, you're going to mess that up. When do two negatives make a positive? When you're multiplying them together or when you're dividing them by one another, yes. But when you're adding, two negatives don't make a positive. In fact, when you add two negatives, what do you always get? Negative plus a negative? Always negative. So what is adding two negatives? It's starting to the left of 0 on the number line and then moving even further to the left of 0 on the number line. Right? Adding a negative and a negative will always give you a negative result. Just for the same reason that adding a positive and a positive always gives you a positive result. And then there are those cases where you have to add together two numbers that have different signs, a positive plus a negative. What do you do in those cases? You keep, well, you might keep the negative or you might not. It depends on.
The sign of the higher value.
Keep the sign of the one which is further away from 0. Yeah, exactly. So let's imagine that, oh, I don't know, imagine I was doing negative 6 plus 15 or something like that. So what would this evaluate to? Positive 9. So we had the positive sign because we're taking the sign of the bigger number, the 15, which is bigger in absolute value than, say, the negative 6. And then where'd the 9 come from? It's a subtraction, exactly. So when you're adding two numbers with different signs, their absolute values subtract from one another. So we end up with positive 9 in this case. It's as though we're starting at negative 6, which is 6 steps to the left of 0, but then we're taking 15 steps to the right, which takes us all the way past 0 over to positive 9. So those little steps of adding numbers with mixed signs, adding numbers with negative signs, those are the arithmetic steps that are very, very easy to screw up. So slow yourself down on those steps and walk yourself through it. The fluency will come later in the semester, but for now, I feel like having these conversations is helpful because I see these mistakes across the board, not just in this class, but even people are still messing around with that even as they go up through calculus. So everyone does it. It's just a matter of minimizing it to the extent that we can. Are we done? Why are we not done? Yeah. If there is a simpler form for this fraction, we need to find it. How do we know whether there is a simpler form for negative 45 over 12? There's a common factor between 45 and 12. Well, what might some common factors be between 45 and 12? 3. Yeah, one of the other tempting things to do is to stop, because the first thing we usually do when we're looking at a fraction is to check to see whether 2 is the common factor in the top and the bottom. That's always the first good mental check, and this fails that mental check. 2 doesn't go into the top and the bottom. So sometimes, if you're in a rush, people will stop here. But check 3. I mean, in principle, you'd have to check every possible divisor to see what goes into it. But 2 is easy to check for. 3 is a little bit harder to check for, but still necessary. So if I divide by 3, the top and the bottom, my denominator goes down to 4. My numerator, negative 45 divided by 3, becomes negative 15. Are we done there? Oh, that's a good question. So what should we do with that negative? I am totally fine if you leave it in the numerator, again, because of my how to handle negativity thing, right? Leaving the minus sign upstairs is just fine with me. If you prefer, you can also put it out front instead, negative 15 over 4. That's fine. Putting in the denominator is also not incorrect. It just looks kind of clumsy, and it sort of, it flies against my how to handle negative signs kind of thing. So I don't know. I go back and forth with it. I still kind of like leaving it upstairs, but that last step is up to you. And again, don't feel the need to convert it into a mixed number. Improper fractions are just fine for your final answers.